Hi, my name is Laura Marie Coleman, and I'm glad you're joining me for this part 3 of addition and subtraction word problem situations. In part 1, we talked about add to and take from problems, and in part 2, we talked about put together and take apart word problems. In this video, we are going to discuss comparison word problems. We're going to look at the 3 types of compare problems. We're going to use the read, draw, write, or RDW approach to problem solving again in this video. We'll read the whole problem together to get a big picture idea of the story. We'll go back and draw or represent one piece of information at a time, and then we'll look at our picture to decide what operation we could use to solve and write an equation. This is also based on the table of information found in the progressions document draft from 2011. Also referenced in Common Core and many state standards. In the comparison problems, the 3 columns across are difference unknown, bigger unknown, and smaller unknown. And then within each box, we have 2 different types of comparison, and this refers to the language used for the comparison in the word problem. Each category for the unknown breaks down into a problem that uses more to compare or fewer to compare. Let's take a look at a compare bigger unknown using the more language in the comparison. There are frogs and ducks in the pond. There are 10 frogs in the pond. If there are 3 more ducks than frogs, how many ducks are in the pond? So we know that we have frogs and ducks. This is one difference from the other types of situations we've gone over so far, because we're going to be comparing 2 different quantities. So instead of 1 tape or 1 drawing, we're going to have 2. So we'll have 1 for frogs and 1 for ducks. We know that there are 10 frogs. We also learn that there are 3 more ducks than frogs. When we think about this idea of comparison, students can represent it a couple different ways. Some students may need a really concrete way to show which items in each group have a partner in the other group, so they're equal. Or they can just think about more and fewer, so it's that longer or shorter as far as the picture of a linear drawing goes. So let's think about seeing the objects in a linear drawing, and we've labeled the parts. So we know that the first part for the frogs and the ducks is equal to 10. And that there's 3 more ducks than frogs. The unknown is the bigger quantity. That's the bigger unknown. We're using more to compare with a bigger unknown, and we can use the equation 10 plus 3 to find that bigger unknown quantity. Let's look at compare with a bigger unknown, but this time we're using the language of fewer to compare. We know Jan has 7 pens. This is 3 fewer pens than Pat has. How many pens does Pat have? So we know we have Jan and Pat. We also know that Jan has 7 pens. We can show the idea of fewer a few different ways. Some people like to dot the extension of the box that would be there if they had that 3 more. Other people like to use a circle so it shows that extension and the space for 3, but it's not adding to the tape itself. My favorite personal one is to use this little bar. It represents if there was more of the tape, that's how long it would be. So you can be flexible, you could show your students a variety of options, or you can just see what they come up with. So let's use this one. We're showing that Jan has 7 pens, which is 3 fewer than Pat. And the question is, how many pens does Pat have? The bigger quantity is unknown. When students are using numbers instead of individual dots to represent each object in a comparison problem, it can be helpful to draw this line down the middle that shows the equal parts in the 2 bars. So that helps us know, we can label that if we know one part is 7, then this part on Pat's bar is also equal to 7. We also know if the space missing, the fewer is 3, then this extra piece of bar or tape in Pat's is also 3. And this means that from our picture we can see if we add 7 plus 3, we can find the bigger unknown quantity. Let's look at a couple compare smaller unknown problems. So in this one, Nan has 23 pencils. Nan has 5 more pencils than Dave. How many pencils does Dave have? We know that Nan has 23 pencils. Because the next piece of information tells us Nan has 5 more than Dave, I'm going to want to break apart or decompose my 23. So I'm going to move that outside of the box so I have room to draw and write inside. Now I can show that Nan has 23 pencils, which is made up of 5 more than Dave has. And then I can see the part that Dave has is equal to the other part of Nan's 23 pencils. I can fill in all the information I know on my picture or model. I can also think about number bonds. Number bonds can be really helpful for students, and when you look at the model, you can see the number bond. I have one part of 23 is 5, the other part of 23 is the unknown, and the whole, when I put 5 and that unknown part together, is 23. So we want to know what number plus 5 equals 23. Here's a compare smaller unknown with the fewer language. Josh has saved $526 and Anne has saved $126 less than Josh. How much money has Anne saved? So in this problem, we know we have Josh and Anne. We know that Josh saved $526, and we know that Anne saved some money that's the same amount as Josh, but then she's $126 less. Even though I use the less language, it does fall in that fewer comparison. Fewer tends to be a harder word for students when it comes to comparison vocabulary. Here I can see the line drawn to show the parts that are equal in Anne and Josh's tape, and how the 126 less that Anne has equates to 126 more that Josh has. I can always go back to that number bond if it makes it easier, and I can see that 526 minus 126 will help me find out how much money Anne has saved since it was less than Josh. Compare difference unknown is the last category for comparison word problems. For this one, we have Grace and Nate went apple picking. Grace picked 27 apples and Nate picked 18. So here's my drawing for Grace, and I see her 27 apples, and Nate and his 18 apples. Difference unknown, the picture is going to be the same. The thing that keeps them apart is the question that's being asked. It can be really great to ask students, okay, now that you have this picture, what kinds of questions could you answer? Students might come up with, how many apples did they pick all together? Or they might come up with these difference unknown questions, like, how many more apples did Grace pick than Nate? And our picture might look like this. Or, how many fewer apples did Nate pick than Grace? And we might have a subtly different picture. I try to be intentional when I model more. I usually put it in the larger quantity, and if the problem uses fewer, I show it on the smaller quantity to help students see how those words are different. In summary, it's important to know that problem situations are based on the events of the story, the information provided, and what the question is asking, and that there's multiple types of problem situations for each operation. The concept that different problems you'd solve with the same operation have different types of stories and situations is what makes word problems so tricky. It's important to be able to identify each word problem situation for a couple reasons. We want to be able to identify the specific problem structures or situations that students are struggling with. We also need to be able to intentionally create word problems with that specific situation in mind, so we can provide them the practice that they need. Thanks for checking out this video, and I hope you'll visit our website, pimaedu.com, for more videos and resources, And also reach out to us if you're interested in some custom PD or instructional coaching for your school or district.